Okay, so our main focus for today is we're going to be talking about compound interest, which is typically what you have in your bank account, is a compound interest in a savings account. But before we even do that, I want to talk about simple interest. An easy way of explaining this is, say, you guys know that I love chocolate, okay? So I want to borrow 4 chocolate candy bars from Bradford. Yep. And Bradford knows that I like chocolate, so he's going to charge me a high interest rate because he knows I have to have my chocolate. Okay, so he's going to charge me 25% interest, and he's going to make me pay it back within a week. How much am I going to pay him back in a week? 25% of what you paid. How much in candy bars? 5, correct, because I borrowed 4 candy bars. 25% of 4 is 1. And I'm going to add 1 back to my 4 candy bars, so I will owe him 5 candy bars next week. Okay? That is an example of simple interest. It's a one-time fee. Okay? So what I want you guys to do is write this vocab down, simple interest, and you can also, on the side, write one-time interest fee. Okay? So today, compound interest is calculating an amount of interest that's compounded yearly, once a year, is this formula right here. Okay? Where A is your future value. P is your principal, or the amount you're putting in, your original amount. R is your rate, and note that that rate is in decimal form. Okay, they'll give it to you in percent, but you got to put it in decimal form. And T is the amount of time that you're going to have it invested. So, for example, if we're investing $4,000 at 6% interest for 5 years, it's going to be 4,000 times 1 plus 0.06, and it will be to the 5th power for 5 years. Okay? If you were to put that in your calculator, you would get the value of 5,352.90. When you are most places will find interest more than one time a year, though. Okay? So your savings account is probably compounded either quarterly or monthly. Okay? So this is the formula that you use when it's compounded or charged, given interest, interest payment more than one time a year. So here's what you're doing. The only difference between this one and the one above it is, note that you're dividing your rate by the number of times you get an interest payment, and then you're taking it to the power of that, the number of times of that interest payment times the years, okay? Yep. So let's do that. We're going to use the same values that we had before. For quarterly, you're going to have 4,000 times 1 plus 0.06 divided by what? 4. And that's going to be to the 4 times 5 power. If you put that in your calculator, you will have the value of 5,387.42. So what I want you to do, I'm going to pause this. I want you to find the monthly value and the weekly value. So I'm going to give you a couple minutes to do that. Okay? So try that on your own. This is what I got for monthly. If you notice, I take my 6% divided by 12. Okay? And then take it to the 12 times 5. You should have gotten 5,395.40.
5,395.40.
5,395.40.
5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40. 5,395.40
Okay? Weekly, you divide it by 52 and take it to the 52 power. Okay? And you should have gotten 5,398.50 there. 5,398.50. Okay, one of the things I want you guys to look at. Tell me, what trend do you see going from compounded annually to quarterly to monthly to weekly? What do you notice? It's increasing. So what do you generally want in your savings account? You want it compounded more frequently, right? Okay? So the more you compound, more that's compounded, the more interest you make. Okay? So, moving forward, there is one other type of compounding, and it's called continuous compounding. That means it's compounded infinite many times in a year. Okay? It's just constantly being you're constantly getting added value. Okay? So that is this formula right here. A equals P E to the RT. Yes. E is that funny number, 2 point whatever that is. I can't even remember off the top of my head. Yes. So you're going to use that funny number in this, okay? You need your calculators on your phones. If you put them sideways, you'll see that E value. Okay? So to find our continuous rate here, if I were to put the same amount in, it would be 4,000 times E. And notice that the rate is now in the power area. So it's going to be 0.06 times the number of years. How many years were we doing? 5. So if I were to calculate that out on my calculator, e to the power of 0.06 times 5. Okay? So that'll be $5,399.44. Okay, is that a huge amount difference between compounded weekly? Not really. I mean, you earn an extra buck. Okay? Okay, so now, what I want you guys to think about is when you have kids, or maybe your parents did this for you when you were younger, is they invested a certain amount of money to make sure that they had enough in the account to pay for your college. Okay? So this is that type of formula that we're going to be looking at. If I want to have $200,000 in 12 years, the question is, how much do I need to put into that account today? So we don't know what P is. That's present day value. A is our future value. So what we're going to do here is we're going to put 200,000 into A. And by the way, this is the exact same formula we had before. It's just solved for P instead. Okay? And we're going to divide that by 1 plus the 7%, 0.07. And it's compounded daily. So we're going to divide that by 365. And that's going to be to the what power? 365 times 12. Okay? If you were to actually put that in your calculator, the first one, your denominator would be 2.31618. Yeah, I just put in the calculator and that's what I got. And then altogether, it'd be $86,000 and $86,349.06. So that's how much you would have to put it into the account today to be able to get back $200,000 in 12 years at 7% interest. This one right here? Yeah. 365 times 12. Uh-huh. Okay, so here's one thing I need to ask you guys, and this is just a little question to see what you know. Can you make that much money in your savings account?
No. Oh, yes, yes, yes. No.
What is your interest rate in your savings account?
No. Oh, no.
It's even, most of the time it's even smaller than 2%.
Oh, you're right.
Okay? I've even seen savings accounts at 0.8%. Okay? So one of the things you got to know is that you won't be able to just put this into a savings account and expect to get $200,000 later. You're going to be learning about that in Money Skill in the next couple days, okay? You're going to notice that to get 7%, you're going to have to invest in either stocks or in CDs or bonds, okay? But the thing about those are long-term investing. And this is also, if 12 years is long-term, okay? It's not like you're going to get it back the next year. So that's just something I wanted to add. Okay, so next, you guys are going to have to really pay attention to this part because, honestly, this definition is kind of confusing. It says the effective annual yield. The effective annual yield, or the effective rate, is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subjected to compound interest at a stated rate. In English. Okay, I'm guessing you guys probably want to know what that says in English.
Yeah.
Okay, it's saying this. It's answering this question. What is the simple interest rate if we convert the compound interest rate to it? Okay, so in other words, we're going from compound interest to simple. And that's just 1 year. So the formula to do this is this one right here. And a yield, once again, is a percent. It's a percent value. Okay? So for instance, we have an example down below. First of all, it wants to know what we would make in 1 year if we have $6,000. And I'm going to just use our compound interest formula first. And I'm going to put it in there at 10%. And it's compounded monthly. So what am I going to divide by? 12. So 12 times just 1 year. If I invest that, I'm going to end up with $628.28. Okay? But the part B asks us, what is its effective annual yield?
Wait, is it 12 times 1?
12 times 1, yep. What is its effective annual yield? Yes. 1 plus 0.1 divided by 12 times 12, to the power of 12, minus 1. Okay? If you put that in your calculator, you're going to get a decimal value of this. What is that value in percent? 10.5. So in other words, in an account with a 10% interest compounding monthly, in comparison to that to a simple interest, this would be what it is in simple interest amount. Okay?
So the minus 1 is just for the effect.
So wait,
Yeah.
it's nothing to do. It's